This is the Tenney altitude temperature test chamber, model number T15.6ST. It is powered by 208 volts AC, single phase, drawing 40 amps. It's suggested that the circuit breaker be set for 50 amps. It also requires compressed air of approximately between 60 and 70 psi. The heart of the equipment, of course, is the chamber. Let's take a look inside. It's a large chamber. The chamber consists of course, the evaporator from the refrigeration system and the thermocouple and sensors that read both pressure and temperature. The chamber is equipped with 15 feed-throughs that are capped off. The main purpose of this chamber is to test avionics or aviation type electronics or other devices that would be used at both high and low altitudes in different temperature conditions. Here's a sample. These are the customer supplied caps that can be used to feed through and have an active live load inside that are epoxied as to make sure that the integrity of the vacuum is not disturbed in any way. We'll take another look. It has a safety interlock on top so that for any reason somebody should try to open the chamber while it is being controlled and operated, it'll immediately shut off the refrigeration and the pressurization system. We've removed all of the covers so we can see the equipment that supports the chamber underneath. On your right side, you have the refrigeration system consisting of the refrigeration compressor and all other components, including the condenser unit that is mounted underneath as well. In addition is the Welsh vacuum pump. This, the altitude is simulated by vacuum. This is what supplies vacuum to the chamber, and the solenoids down here are controlled by the electronics up top so that you can not only pull down and produce a high altitude, but you can also revent and go to a lower altitude, actually below sea level. Did you get that last? The vacuum pump does require an exhaust, and it is also equipped with an oil trap that can be drained back into the pump with the convenient little valve right here. This is where the air connects to the system. Of course, is used to pressurize the chamber when we want to return back to 0 altitude or sea level, or to pressurize the chamber to below sea level. This is the air dryer that guarantees that the air that going in this chamber is as moisture-free as possible. And we have a flow meter here that we can set so we can decide the rate at which we want the chamber to pressurize. This is the control unit that controls the chamber and all of the different mechanical devices underneath here. This is the Watt-Low F4 controller that allows you to set the different set points for both altitude and temperature. In addition, there is a vacuum guard, and what this does is this does not allow you to go below a certain level, as well as there is a temperature guard. In addition, there are both alarms for vacuum and pressurization and a separate alarm for temperature as well. Normally it's run in an automatic mode from the controller, and it also includes a Honeywell chart recorder. Now I think what we'll do is we'll operate the chamber, and first set point that we're going to put in is we're going to operate the chamber to 100,000 feet above sea level at ambient temperature. It's understood that the instrument also has a safety device that at 65,000 feet will turn off both the refrigeration or the heating process, because over 65,000 feet you really cannot use those two things. Why don't we start with just setting this up? It's very simple. Set point 1 is altitude, so we'll set the altitude all the way up to 100,000 feet, and we will leave the temperature adjusted to ambient or room temperature. The control will operate everything. It's just one push of the switch. And now it'll start to progress upwards towards 100,000 feet. Next, we will change the set points, and we will now set it for 2,000 feet below sea level. Leaving it still at ambient temperature. And of course, to go below sea level, we don't use vacuum, we use pressure. Hold on. Just keep shooting. We're now once again going to change the set points. This time we will change the altitude to 60,000 feet. Oh,
went too far. Hold on. There we go. There's set it to 60,000 feet. But we're going to set the temperature to minus 20 degrees C. And here we go. Now for this fourth time, we're going to reset the controller. We're going to leave it at 60,000 feet, but we're going to run up the temperature all the way to the maximum that the machine will allow, which is 100 degrees C. And here we go. One of the accessories that is installed on the control unit itself is also underneath here. Very convenient. This is an auxiliary regular 120 volt outlet that is separate from the power to the chamber itself, but has an auxiliary plug here that you can plug in. And what's nice about it is if you have other test equipment that you need to hook up to the instrument, it is controlled by the controller, which is very convenient, especially if you're have critical measurements or other measurement equipment that you are using through the feed-throughs into the chamber. When you are done testing your product in the chamber, you can quickly return the chamber back to atmosphere or sea level. As you can see, the chamber is still under vacuum. Presently, it's still at 29,000 feet over sea level. However, you turn off the vacuum and pressurize the chamber. We can quickly bring this back up to, or rather down, in altitude to sea level.